Hi, Sarah Miller from the Crisis Tech Center in booth 711. I'm pleased to introduce Greg Brunel from One Concern, who's going to talk to us about big data and AI. So with that, Greg, it's all you.
Thank you. Thanks for your patience while we got started this morning, or this afternoon. So welcome. So Greg Brunel with One Concern. Previously, I started out my career as a firefighter. So I'm a little limited as far as how much technology I can understand and utilize, so bear with me. We pretty much lay it all out here as far as what I know, but our booth is over across the center today and be happy to sit and talk more in depth about what we're doing at One Concern. I was a county emergency manager, I was a county fire coordinator, and then I was the first deputy for New York State for a long time, and then a couple of weeks into Hurricane Sandy, the governor made a change and put me in as Director of Emergency Management for New York State, and then I became a consultant. So I was real excited to join One Concern about a year, or no, just less than a year ago. But let's talk about AI, ML, and big data, because these are terms we hear all the time, and we hear them in all sorts of spaces, and we don't really understand what they mean. We think we know what they mean, but we don't really understand what they mean, and they're going to be things we hear more and more. And that's partially because government is a little bit slow in adopting new technologies. Now, that's a good thing. It's a good thing that we're slow in adopting the technology in so much that we have to be a good protector of the people's money, of the processes. We have to make sure the companies we're working with are financially sound and stable. But it can also mean we're a little limited in what we can do, and that interoperability, as we just experienced between, frankly, Mac, Apple, and PC was a bit of a challenge, but that's okay. We overcame that. So new and emerging technologies to talk about, or to bring us up to speed to the 21st century and where we're going from here, because the change we're going to see is going to be rapid. The basis of all of our emergency operations centers and our basic programs are pen, paper, and telephone. And right now, every one of our COOP and COG plans for our EOCs is we'll just go back to pen and paper, and we say we can do that all the time. And that, frankly, is almost good enough to get done what we have to do, but it's not sufficient given the technology that's available to us now. And over the course of the last 20 years, with the introduction of mobile technology and cellular phones and what have you, and I had a bag phone back in the day. I'm sure some of you did. Some of you were probably a little too young, but we all had the $400 bag phone and 3 streets in our community that you could actually make a phone call on, and nobody we knew had a cellular phone to call us back. But it was the money well spent to get the technology moving. But the phones now and the smart technology in the field, that's great. That's connected us so we can talk more. Okay? And let me back up for a second. What's the goal of the EOC? What's the goal of the Emergency Management Enterprise? At its basic level, it's about shared situational awareness to support logistics and mission assignment to help those that are affected by disaster and have survived disaster. So that's what we're trying to do, is achieve shared situational awareness, what's going on. And we've increasingly used some level of technology to do that. Now we have the phones that have increased, but a lot of that is giving us access to a lot of deep bench information. We can Google things from the field and find out information. We can go to government websites and get information. But a lot of the applications we're using in support of SaaSs, or software as services, that are the backbone of our EOCs, is about field reporting. How can I check in and say there's damage here, or check in and say there's damage there? And then we rely on the public to be using neat and exciting things like social media to tell us what's going on in the field as well. But it's not really analytical. It's still data. It's still data created by humans in many ways, and that could be raw, and that could be very limited. We tie that together with computers. And this is probably a computer right from somebody's EOC, probably my old county's EOC still to this day. Computing has come a long way, and we were slow to adopt computers, and most of that was just to replace that pen and paper. We were really using it for word processing, and in many ways to get our IAPs done now, our incident action plans in our EOCs, we're really using computers with fillable forms to get that done. Are we really leveraging the power of computing available to us now in order to analyze the data and the information and achieve that highly reliable, highly accurate shared situational awareness? We know how far and how ubiquitous computing and smart technology is. This doesn't even represent the Internet of Things and how all the devices around us are intelligent and censoring what's going on around them as well and bringing them back. We also know that the power of computing in our hands has gone up significantly, and I'm not telling you anything that you don't already know, but your smartphone in your hand is about 10 times smarter than the GPS satellite circling the Earth right now. The amount of computing power we have is incredibly powerful, and we're just not leveraging it the way that we need to be and the way that we can. And AI and ML is going to help in that by leveraging that big data. We spent the last 30 years connecting computers and people, and now we've started to connect not just computers and people across the entire globe, but the tens of thousands of disparate data sets that exist. The information we collect, whether it's at the local planning department and homes assessment location, or it's the National Weather Service, or it's information you collect after your last disaster, we have all that in electronic and sometimes physical file cabinets. We haven't brought it all together to really help make analytical and smart decisions. And even when we do bring all that data in, we're limited by how much we can consume and process, because there's human beings in there, and because there's just too much going on as we move forward. So what are we talking about with data? Real quick on that definition of big data. Data are the elements that we need to understand what's happening. So if it's a single car motor vehicle accident through the 911 center, or it's a tornado, we're actually looking for the who, what, when, where, and why, and hopefully we're translating that into information. National Weather Service does a phenomenal job, and some of the for-profit organizations out there too, to give us real good weather information and turning those disparate data elements into information. What we have to do as emergency management leaders and public safety leaders is provide analysis to get to that shared situational awareness as to what's going on with the incident. What we've done for 30 years is we've added screens, which is just another way to layer in more information coming at us. So we say, okay, well now there's 3 channels that do 24/7 news on top of your local channels, so add those to the EOC. Okay, now we have traffic cameras, so let's add those into the EOC or the 911 center. Now we have social media, so you better have a Twitter screen and a Facebook screen and a Vine screen and a Periscope screen and everything else. And now we're adding drones, which is awesome, and UAVs are great technology, but it's still raw data and information coming into us. It becomes very overwhelming. We've created some really cool dashboards, not one concern, but other solutions are out there for dashboards, which is a different way to landscape and interpret data. And there can be a little bit of analysis behind that, but basically it's still relying on you and me to figure out what's going on, interpret that, to support our own decision-making and executive decision-making above us, our principals, our governors, our mayors, our city councils, and our other public safety leaders in our communities. But when we're making those decisions, when we are consuming that data, we're very limited. In 1958, this paper, The Magical Number 7, plus or minus 2, was published. And it is the most cited paper in the history of psychology. And it's been supported thousands of times through thousands of additional and research on the same concepts. Human beings can only consume about 7 chunks of data at a time, which is why your telephone number is structured the way it's structured. Beyond that, we start to forget. We can't consume it. And for each of those chunks, as we process those chunks together to come up with very viable outcomes, we can only come up with 4 to 8 outcomes. That's very limiting. How do we do that? And let me point out real quickly, as we all know, and we hear this frequently about self-care. When we're in a crisis, we're stressed, we may be sleep deprived, we're probably not eating the best, remembering to drink enough water. All of those affect our cognitive processing. So when we say and we nod and proudly say, well, we're making the best decision we can with limited information, we're also doing it at a time when our brain computing power is limited or diminished as well. That's why we can bring the support of AI and ML to that. Real quick, how do we make decisions day to day? If you had 2 things to choose from, 2 cars, or 2 apartments, or 2 houses, what's a process you could go through to choose between those 2 things? Anybody? You have an idea of what you could do if you had 2 cars? Go ahead. Right. So maybe a pro and con list. You could do a pro and con list, and we do that all the time. We look at the pros and we look at the cons. So Charles Darwin did this when he was making a decision as to whether or not to get engaged to Emma. So Charles Darwin sat down and he said, all right, so here's the list of pros for why I should get engaged to Emma. Now, some of this language is a little antiquated, so forgive me for it. And here's his list, right? That was the pro list. And then he made a con list, reasons why he didn't want to get engaged. Some of this may not have been specifically about Emma, at least I hope the relative comment wasn't. Some is just about getting engaged overall. Now, because I put their names together, you can surmise that Charles and Emma actually ultimately got engaged. And very romantically on the bottom of it, he wrote quod et demonstratum and handed her the list and asked her to marry him. And against probability, she said yes. But the fact of the matter is he went through a very simple process that we do all the time. And he said, look, 6 pros, 5 cons, I'm making my decision. This is my decision boundary between these two lists. I touched the screen and I promised I wouldn't. I'm making my decision between these two lists because this probabilistically outweighs the cons. And he got engaged. Benjamin Franklin called this the first human algorithm, and that's exactly the concept behind artificial intelligence and machine learning. It takes thousands and thousands of disparate data elements, layering it together and considering it and adding additional dimensions, and I'll show you that in a second, to come up with the most highly reliable and probabilistic outcome so that it can support our decision making. It doesn't replace us. It doesn't take us over. Not yet. It doesn't replace us. It supports decision making so we can make better, more informed decisions with data elements we wouldn't normally be able to consider. So if I say to you, hey, listen, it's sunny today, and you're trying to figure out F the weather, well, sunny tells you something. And you could say, if I said, hey, tomorrow it's going to be sunny, you'd say, okay, it's going to be a nice day here. Well, you already have other X's, other variables in the back of your mind, because you know you're in Southern California, you know you're near a big body of water that keeps it temperate here, and you know that it's really not the depth of winter yet, right? So really, to come up with a forecast, we need to know it's sunny and where am I? And it's sunny and where am I? And what season is it? And what's the humidity and the wind direction? And you and I can't do that, all of those data elements. We can do the big ones, but to get a highly reliable forecast, we need thousands of data elements. And the computer can consider that. So let's go to damage assessment for a minute. If I'm getting Twitter feed reports in after an earthquake in my community that says, on this street, this linear path, I've got damage clumped here and no damage clumped there, well, I can easily put a point down and say, boom, this is where the damage is, this is where the damage is not. But in a neighborhood where I've added another dimension to the space that I'm trying to consider, now the data gets a little corrupted on that linear path. So I need to add an additional dimension. And this is what the computer does with the spatial dimension in this case. The computer can also consider, well, HAZIS, for instance, models itself on 2 data points for every structure in the United States. It's basically F equals MA, which is Newton's second law. Contemporary algorithms, one that I'm very familiar with, uses more than 450 data elements, which sounds like an exaggeration, but that data is out there. We just haven't brought it to bear. Well, when you're talking about 450 different data elements, it's difficult to plot that, and it will be corrupted in 2 dimensions. So a computer can add additional dimensions and does this in nanoseconds. So we add a 3rd dimension, which we can cut with a plane. And when the computer still can't find that decision boundary as to whether or not there's damage and then to what degree of probability and severity there's damage, it will add additional additional dimensions and additional dimensions and do that automatically and find different decision boundaries in multiple dimensions and output for us 86% likelihood that this building is damaged to a level that people cannot occupy it or that people are trapped. And when we go through that process, artificial intelligence becomes a very powerful solution, and machine learning become very powerful solutions to use those tens of thousands of disparate data sets in the natural and built environment to help us target our responses right away. And in the Marvel universe, it also creates Jarvis, which we're not quite there yet, but we will get there. Right now, we have a lot of great tools out there that we've changed the topography and the screen color and the data elements and how we consume that information. We've added more and more data to it. With artificial intelligence and machine learning, we're able to hit that knee of that curve and elevate very quickly. So we'll be more powerful, information behind us, and we can make better decisions during times of crisis to help those people that are counting on us to be there for them when they need the help the most. So thank you very much.
Thank you so much, One Concern. It's really wonderful to hear about how technology really is going to change what we're doing and change how we're able to respond. Our next talks are going to be up this evening. So the talk tonight is about the fantastic wall behind our person here. This is a direct view LED video wall. If you want something shiny like this in your EOC, or you at least want to learn more about how it works, please come and listen to Don Fisher, one of our ETC members, talk about that wall. And again, if you have any questions about technology conversations we've had today, you've seen us talking on Twitter and you want to finish that conversation, feel free to stop by, check out our 3D printer. play with our virtual reality setup, and thank you very much.